Alright, so today we're going to be discussing a little intro into the normal distribution. So this is where you probably should start taking notes. Okay, it's not really a big picture day. It kind of is and it kind of isn't. I'm not going to let you sit around and waste an hour and a half of time. So, game is this: the normal distribution is symmetrical. It's bell-shaped, the bell curve, if you will. Yay. And so whenever you tell me something is normally distributed, it's going to have this general shape. And we'll write it this way. We'll say that whatever it is distributed. That means is distributed. Normal, when I see n, that means normal. And then you're going to tell me the mean and then the standard deviation in that order. Okay, so the heights of United States adult women are distributed roughly, are distributed normally. 66 inches is the mean, 2 inches is the standard deviation. That means, of course, and I've drawn this for you before, 66 is in the middle, 68, 70, 72, 64, 62, and of course 60. Okay, and we've counted them off by standard deviations. Now, as you recall, we talked about, we made z-scores out of things. Well, whenever you make a z-score, it turns out you're doing something that's really kind of special and neat and awesome. Okay, and what you're doing is that you're changing, you're shifting. Instead of being centered at 66, it's now going to be centered at 0. And instead of having a standard deviation of mu, or a standard deviation of sigma rather, it's going to have a standard deviation of 1. And so what we say is this: z is distributed normally with a 0 and a 1 for a mean and a standard deviation. So when you hear normal 0, 1, or a z, what we really are talking about is what is called a standard normal distribution. Everything we will do mathematically will revolve around the standard normal. Okay, that's just what we're going to be doing. And so you may recall that some chapters ago, in chapter 3, yes, chapter 3, we talked about the empirical rule, and we said, all right, here's the mean, whatever. Within one standard deviation is about 68%, yes. And within 2 deviations was 95%. This is nothing new. And within 3 deviations is 99.7% of the population. Well, today we can get to do different amounts. In other words, we can find out things that aren't exactly 1 deviation or 2 deviations. It could be 1.7 deviations. Okay? So, for instance, let's say the test scores. Some test scores are normal and they have an average of 85% and they have a standard deviation of, I don't know, 10%. So what is the probability, or another way of saying it, so we'll say this way: what's the probability that a person scores less than a 72 on this test? Now this says probability. Another way of saying this could be what proportion of the people scored less than 72, or anything of that nature. There's a variety of ways to say that. So here it is. So what I'm going to do is I'm going to convert an x, I'm going to convert it to a z. To do that, I'm going to make a z-score. So it's going to be 72 minus 85. It's going to be a negative z-score, of course, because it's below the mean. So here's the game. We're going to go from here to here. Whee! And here's 0, of course, here. And here's negative 1.3 standard deviations. I want to know how much is from here down. Now, wait a minute, Mr. Groom. Are you saying that it's less than 1.3? Well, that's what I'm saying, actually. Well, the normal distribution is a continuous distribution. And so we want this. And so it's a continuous distribution. So here's the thing. There's an infinite number of possibilities along a number line. So the probability of any one number, that x is equal to some big x value, like for instance, what's probably it's equal to exactly 72. The probability of that happening is exactly 0. So this, in a continuous distribution, is always the same as this. Okay? So then the question then becomes, well, wait a minute. I have a formula for this before. It was what's called a CDF. And you're right, we do have a CDF. Okay? So this is what's going to tell us a CDF, a normal CDF, because a z-score is a normal distribution. A normal CDF is in our Google Sheets. So if you open up your Google Sheets, I will go onto mine, and I'll open a new, no, maybe I won't. Maybe I will. Okay, I guess I will. Sure. This is a nice one, I guess. There we go. Again, all I need is a clean worksheet somewhere. So, come on, open up, piece of garbage. There we go. So it's equals norm norm s dist. Now, I will say this: the difference between Excel and Google Sheets is it's norm s dist on Excel. Okay? I'm going to type in negative 1.3. Hit enter. Okay? What that tells me is the probability that I am less than or equal to this. Oh shoot, and I didn't pay attention. What percent was it? 9.6%. So from here down is 0.096. So back to the top of the page, what percent of the people scored less than 72? 9.6% of them did. Okay? Now you're like, well, do another one. Love to. Yeah, sure. What percent of American males are between 68 inches and 75 inches tall? Well, I don't know. Well, oh wait, you didn't tell us, Mr. Grimm. So here, their weights are distributed normally, have a mean of 71 inches and a standard deviation of 2.1 inches. Is that right? That's close. I can't remember the exact figure. So what do I have to do here? Well, what I'm going to have is this. Here's my normal distribution. Here is 71 rather in the middle. So if I count over 2.1, it puts me like it's what, 69 something ish. So like 68 is going to be here, yes. And then of course, if I count over a ways, 75 is going to be over here somewhere. Okay. So the question is, what percent are between here and here? Well, this time I'm going to need two z-scores. So one of them is, let's call it z1, 68 minus 71 over 2.1. And the other one, of course, is 75 minus 71 over 2.1. And so I'm going to say equals parentheses 68 minus 71 parentheses divided by 2.1. There's one of my z-scores, and then do it again. Booyah. There's my two z-scores. Okay? Negative 1.43 and 1.9. Okay? So, what we're saying here is this. I want to know what's the probability you're between here and here. That is the same as the probability that your z is between 1.43 and 1.9. Those are equivalent. So instead of finding this, I'm going to find this, because that's how we're going to roll with it. We're going to do it with a standard normal, a z-score. So let's try that. So if I taking that off would help. Equals norm s dist. Okay. So I'm gonna. So here's the deal. You're like, well, how do I type them both in, Mr. Grimm? Do I use commas? Like, do I do this, comma, this? Ooh, Betsy's not happy with that. Ah, golly, what am I gonna do? So here's the deal. What happens is this, in a situation like this, when you want to find them in between, what you're gonna do is this. So from here down, I can find a percentage, yes? Let's do that. And so equals, come on, get on there, you hippie. Equals norm dot s dot this, which is that guy right there, of this dude. So it's about 7.6% from here down. Well, I wonder what it is from the top one all the way down. I don't know. Let's ask Betsy. Equals norm dot s this, that one right there, of this fella. Why, it's 97%, Mr. Grimm. Weird. So from here down is 97%. So 0.97. Well, how much is between them then? Well, awfully close to 90% then, I reckon. So you simply go equals this dude minus this dude. Voila. 89.5%. And the answer is that. 89.5%. So when I asked you what percent of the American men are between here and here, you say it's about 89.5%. Ta-da! You guys are playing some beautiful music over there. What's up with that? Alrighty then. So here's another example. Yes, ducks. Mallard ducks, sure. That's important, Taylor. It's important that they're mallard ducks. Mallard ducks. You know the kind. Mr. Grimmer, you're going to draw it with a green head. Yeah, give me a minute. Okay. This is what I do when I have to make videos after school because I get bored and I just randomly start drawing. Oh, shut up. They got a blue in there somewhere, don't they? I think so. And I don't know, it's been a long time since I've been around with those dumb ducks. All right, there it is. Anyway, whatever. Now, nice. Turns out that their weights are distributed normally. 3.2 pounds. Standard deviation of 0.891 pounds. What's the probability that we get a duck that weighs more than 4 pounds? Okay, now listen. I was just saying the probability that I get a duck that weighs more than 4 pounds. Another way of saying that is what percent of the population of ducks weighs more than 4 pounds? Well, I don't know. But I do know this, that here is 3.2. 4 is about here somewhere, right? So I want to go from here over. Now you're like, wait, Mr. Grimm, are you saying probably x is greater than or equal to 4? Yes. Hey, that's not a CDF. This is a CDF. That's right, it is, right? It equals 1. But you're like, wait, but I don't have this less than or equal to. Remember, these are the same because the probability that it's exactly 4 is equal to 0. So whether you include the equal sign or not equals, it doesn't make any difference. It doesn't change anything. Okay? Hey, this is a CDF. That's right, it is. But we have to make a z-score first. So we're going to say, are you okay, dear? 4 minus 3.2. We have special in-studio audiences today, AJ and Abby. Yes, they've come to the taping of the J. Groom shoe. So, 4 minus, oh, for God's sakes. I forgot what the problem said. So, 4 minus 3.2 divided by 0.91. So I get a z-score of that. So if I do equals norm s-dist of that number, you'll see I get about 81%. Now what did that tell me? Okay, well that's telling me from here down. So because this is the same as, what did I say, 80 something? 0.88. That's my z-score. plus the probability that x is greater than 0.8 equal to 1. Well, I'm telling you this is 81% plus this value here, or whatever. It's whether I put the equal there or not, it's unimportant. So if I subtract it over there, I get about 19%. That's the answer that you seek. This is 19%. This is 81%. Piece of cake. In other words, 19% of all mallard ducks weigh in excess of 4 pounds. That's what we're saying. We'll do that problem. Okay. So we're going to be doing some of that today. It's pretty straightforward. Matter of fact, in the first part of the lesson, it's going to be something along these lines. It's going to tell you, hey, look, z is equal to 1.4. What percent is down here, Mr. Groom? Well, equals norm s dist. By the way, if I keep saying .s .dist, it's because I'm used to doing it in Excel. Don't freak out when I say that, okay? Whatever this spits out is the answer to this problem down here. Bloop. Also, you're going to be seeing some of these dudes where, oh, look, 1.1, Mr. Groom, but I want this part. Then you're going to do equals 1 minus norm s dist of 1.1. This portion here will give you this amount. 1 minus it will give you the upper piece. Okay? Pretty straightforward. Now, the other thing we're going to be looking at in this chapter a little bit, well, the next first day or two here as we're messing around, will be, well, Mr. Grimm, I want the smartest, I don't know, 10% of the population. I would like the shortest 5%. Okay? I mean, listen, I don't know, Ethan, you only want to date the shortest 5% of the women. I don't know why, you weirdo, but there it is. And so you need to have this cutoff that says, look, if they're 5'2" and a quarter, they're short enough for me. Anything less than that, we're good. Anything bigger than that, it's a little weird, Mr. Groom. Okay, so let's start off with this one. So again, Ethan, we know that their women are normally distributed heights, like so. So here's what I've got. What I've got is, I'm starting off with a percentage. So that's 0.05 down here. What I need is a z-score. So what I need to do is do an inverse normal to get myself to take a percentage and have it spit out a z-score. Okay? Now, how does that work on this deal? Well, it turns out it's equals norm s inverse. Do you see it? Boom. And it's always the area to the left. So negative 1.64, area to the left. So my z-score is negative 1.64. So, Ethan, what you're going to do, friend, is you are going to solve for x. So how do I do this? Well, I times both sides by 2, so I get negative 3.28. X minus 66 plus 66 to both sides, and you will find that you get 62 and 0.72. Any girl that is less than 62.72 inches tall, you can date them. You're like, but Mr. Groom, I feel like there's a girl in this class right now that's like 5'2" and 3/4 of an inch. Okay, pal. That's just a skosh bigger than this. Sorry, she is no longer in the smallest 5% of the population. Okay? Now you're like, wait, is that similar to what we did earlier with percentiles, Mr. Groom? You know what it is? So, I don't know, some girl in the room, it's 5'9". I don't know who you are. Courtney? No, I don't think you're that tall. I don't know. Whatever, it doesn't matter. Mr. Groom, that's 69 inches tall. That's true. What percent of women would be shorter than that girl? I don't know, but I bet we could find out. So here's 68, of course, and here's like 70, I feel like. So that's right in there. Is where 69 is, okay. So I need to make a z-score. So again, it would be 69 minus 66 over 2, which of course is 1.5. So then, if I want another percent that's less than that, because that's literally what the definition of percentile is, with this normal distribution, a person could do equals norm s dist, boom. Yep. And then 1.5er, and this person would be in the 93rd percentile of height. So this girl would be. Pretty easy, huh? Now, so Suppose that oh boy, yes, you'd like to have the best scoring math students in a class. Wouldn't you like that? So the top 15%, you'd say. That's what you want. Well, it'd look like this then. That's, by the way, that's completely a normal curve. Duh. Just in case you're wondering. 15% over here. Okay? So I'm going to do norm S inverse, of course, but of not 0.15, 0.85, because that's the amount that's to the left, and that is how it always works. Because in essence, you're taking and undoing a cumulative density function. Shoot. What happened? That's weird, yo. Yo. What? No, whatever. Equals norm S inverse 0.85. Come on, Betsy. 1.036. So this is a z-score of 1.036. Now what happens, Ivy? Put your phone down, pay attention. What would happen if you accidentally put a 0.15, or darn it, 0.15 in here instead? What, Mr. Groom, it's the same z-score, except it's on the bottom end. Yeah, I'm aware of that. So here's the dealio. If you had 0.15 down here, or 0.15 up there, you will get the same z-score number, except it'll be negative. Are you with me? So if you make a mistake, don't slap yourself in the head too hard. Just drop the negative sign. That wasn't that hard, was it? I didn't think so. So that's what I do. That's what I shouldn't say that's what I would do. It's what I do when I screw these things up. So on this test, the average on this test, so again, our test is distributed normally. The average on this test is 3,162 points with a standard deviation of 211. Why would you do that? Why not? X minus this fella over 211. And then so it's simply a matter of doing a little bit of algebra. So, times, what is wrong with this thing? It's getting on my nerves. You're annoying me, you stupid computer. There we go. Equal this fella. Boy, everything is annoying. Yeah, I don't. Equals this guy times 211 plus the mean, which was 3,162. Voila. If a person scored a 2943 or better on your test, 2943 or better, they are in the top 15% of the class. That's it. Now, on the first assignment, what you'll end up with is something very straightforward and very almost boring. It'll give you something like this. 21% down here. Can you find this z-score? You know I can. So it's simply going to be equals norm S, norm S inverse 0.21. That's my answer. I know it's right because it's going to come out with a negative z-score. Yes? I don't know what it is. Fine, I'll look it up. Don't make fun of me, Falk. That's mean. All right, now, equals norm S inverse 0.21 negative 0.8. That's key. And then you're like, well, wait, do another one, Mr. Groom. Love to. 0.31. Weird. Clearly, that's above the midline. If it was at the middle, it would be equals 50%, of course. This is not. And if I put in 0.31, look what happens. Oh, geez, it's a negative z-score. That can't be right. This is clearly a positive z-score. This can't be negative. Oh, SMH, right? Hashtag Whatever. Bonk yourself right in the head, dork. Now listen, here's the deal. It's 31% from here over. This is not what Betsy wants to know. Betsy wants to know from here this away. So you're going to type in 0.69. And then you're going to stand back and be amazed at the answer. OMG, gosh, it's the same. That's right. Z is equal to oh crap, I can't remember what I said. 0.495. In other words, about a half a deviation. 495. Now remember, that is the same number you got a minute ago when you put in 0.31, except you got negative 0.495. Okay, so you're going to be doing that in the first section today of the homework. It's nice, easy ones that are like this and like this stuff. Okay? Those are the ones you're going to be doing on the assignment, the first assignment. After that, you're going to do problems like the mallard duck and this business here and this guy down here. These are the guys you're going to be doing in the second, not the first assignment, but the second assignment. And it's from here on where things get interesting. Okay, so you need to practice with that today. It's probably enough. Homework sheet's going to get passed out in a second, and good luck to you. Bye. All right, what can I do for you peeps? You need